Hello, this is about working out Möbius transformations, which are transformations like this, equations relating one complex number to another. We can't draw graphs of these transformations like we draw graphs of real functions, because to do that we would need four-dimensional graph paper, 2 dimensions for z and 2 dimensions for w, and we don't have four-dimensional graph paper. So the way we do it is by drawing diagrams of paths in the z plane, paths that z follows, and then draw diagrams of the path that w follows when z follows that path you started with. And the thing about these equations is when z is a circle or a generalized circle, w will also move on a generalized circle. So here's how to work it out. First, draw your z locus, or the path that z moves on. So here I've assumed that z is moving on a circle with centre of the origin and radius 1. And the equation of that is mod z equals 1. The distance of z from the origin is 1. And here's the equation of which gets w from z. So after drawing this path of z, or z locus, I draw in the pole of the transformation. The pole of the transformation is the point where it blows up, where you would get an error on your calculator if you tried to work it out. And this blows up when z equals 2, because then you're trying to divide by 0. So here's your pole. Z equals 2. Then mark in the 2 diameter points of the z path which are in line with the pole. So there are only 2 of them, and what they are is, in this case, is z equals 1 and z equals minus 1. And the w locus, the path which w follows, will be a circle, and which circle is defined by the fact that this diameter of z transforms into a diameter for w. So all we have to do is to work out what w values we get from these z values. So z diameter minus 1, 1. W diameter put minus 1 in for z, and w is 0. Put 1 in for z, and you've got 1 plus 1, which is 2, divided by 1 minus 2, which is minus 1. So 2 divided by minus 1 is minus 2. So here you have w is a circle with diameter ends 0 and minus 2. So there's your w locus, minus 2 and 0. That's it. If you want to work out the centre of the w circle, it's just halfway between 0 and minus 2. If you want to work out the radius, it's half the distance between 0 and minus 2. If you want to work out the equation of it, it's w minus the centre, which is minus 1, minus minus 1 is 0, is equal to 1, which is the radius, square that up, and it will give you the equation in terms of the real and imaginary parts of W, which are normally written as U and V.